Hello, good afternoon, everyone. Let me get my pen. I'm running a succession of lessons, OCR chemistry, A-level. But before we get to the actual content of the lessons, the A-level syllabus rather, I think it's essential that we follow or cover some GCSE topics that I normally teach my class when they start AS. To fill up some gaps and holes in the learning. So I've labeled these lessons as Lesson 1 GCSE AS Foundation, things that I feel that you guys need to know before we move on. The other approach I'm trying to use in these lessons is that I try to teach them like as if I'm teaching my lessons in my class. It's not going to be very regimented, but it is going to be very focused on the topic. And we'll see how it goes. We'll see how it goes. I try to treat you, the wider audience, in exactly the same way as I do my own students. Yeah. The only problem is that you guys are not here, so I cannot tease you as much as I do these ones. I think I have written about 50 topics so far, and it's still not finished. Lots of other areas still remain that I need to do, but I'm trying to have these clips something like 7-8 minutes so you guys don't get too bored. The first thing that I thought we talk about, and discuss with you is the periodic table, and mainly the trends in periodic table. You see, if the periodic table at any time that you want, when I put questions on the board, when I ask rhetorical questions, when I discuss something, the advantage as regards you guys are concerned, you can always pause and have a look later, yeah? Or if I'm asking a rhetorical question, you can pause and see, because the answer usually follows immediately afterwards, you can pause at that moment and see if you can answer it. We'll see how it goes, yeah? We'll see how it goes. The periodic table, the 118 elements in the periodic table, most of them are metals. The first thing you have to establish is what is a metal and what are non-metals. Of course, metals are elements that want to lose electrons, and non-metals want to gain electrons. That's it. They want to lose, they want to gain. But what is the order of losing, or what is the order of gaining electrons? The trend, rather. Nobody is going to ask you to talk about the chemistry of cobalt or nickel in detail as far as periodic table, but as far as the A-level syllabus is concerned, you guys need to know trends. The general trend is that if you put your hand in the middle of a periodic table, that perhaps you have one in front of you somewhere, as you go towards the right, they become more and more non-metallic, right? And as they go up, they become more reactive as non-metals. As you go towards the left, they become more and more metallic in character. And as you go down, they become more reactive as metals. It means they intend to lose electrons better, and as you go down, faster. So the general trend, reactivity of all the elements in the periodic table is right hand right up, left hand left down. Of course, I mean, there may be exceptional cases here and there, but this is the general trend. So when for example, I'm looking at the periodic table, it is not in the screen, but for example, we've got nitrogen, oxygen, and fluorine on the right-hand side. So as you go towards the right, fluorine, of course, is more reactive than oxygen, and oxygen is more reactive than nitrogen. But but as you go up, say fluorine is more reactive than chlorine, or chlorine is more reactive than bromine. As you go towards the left, so for example, you're looking at something like, transition metals, boring metals, in terms of reactivity. That's why we use them quite often, because they don't react that much. Things like cobalt, nickel, iron, as steel, copper, of course elements like platinum and gold, they don't react at all, more or less. But then as you go towards the elements that you are required to know, things like group 2 elements, like for example in group 2 beryllium, magnesium, calcium, as you go down they become more reactive. But as you go from group 2 to group 1, they become more reactive. So, for example, potassium is more reactive than calcium. They are in the same period, but potassium is in group 1. So the other thing that you need to know is, well, okay, that's all very well, but why? And this is something that I want you to keep in your head, keep in your mind all the time. Nuclear attraction. Nuclear attraction. All right? And that nuclear attraction, nuclear is positive. Positivity sign. And what is it attracted to? To the electrons in the orbitals. Right? Now, I mean, it therefore follows that if you have, for example, let's consider something like fluorine on the right-hand side. Fluorine has only 2 shells. The nucleus is here. And it's got 7 electrons here, right? So if there is an electron there, because the nucleus is just round the corner, it's going to attract that electron much better. Because remember, these guys are in the business of gaining electrons, right? The reactivity of nonmetals is about gaining electrons. When it goes from fluorine to chlorine, there is an extra shell out there. So the nucleus is further away from the outer shell. So the nuclear attraction towards the electrons to attract them into the third shell is going to be lessened, is going to be weaker. And it is because of an extra shell, which we call the shielding effect, right? So the nucleus basically is shielded more, or in some cases, shielded less. But don't ever forget the idea of nuclear attraction towards electrons. Protons are in the nucleus, right? So they're going to attract electrons. So as far as the nonmetals is concerned, perhaps it is quite obvious as to what is happening. What about the metals on the other side? Well, okay, these guys want to lose electrons, right? So now the idea reverses. Which elements are going to lose electrons? Better, easier, with less fuss, with less energy? Well, the ones in which the nuclear attraction is weaker. So when we're talking about, say, for example, potassium, which is in period 4, it's got 4 shells. And it wants to lose that electron. And obviously, the attraction, the nuclear attraction from the nucleus towards that electron is lessened. Is lessened. Is far less than if, for example, it had only 3 shells and that wasn't there, and the electron was from the 3rd shell, which was sodium, right? Because that electron, it would be more strongly held than this electron in the outer shell. The idea is that these guys want to lose electrons, so for potassium to lose an electron to turn to potassium ion, it would require less energy, right? Because there is a stronger shielding effect, because there is one extra shell. And as you go down to elements like rubidium and cesium, it becomes even more enhanced. With below potassium is rubidium, so rubidium has got one extra shell out here. So the nuclear attraction is even less than it was with potassium. So things that you have to remember in terms of the periodic table, to make this video quite short, because there isn't really much more to say. Of course, there's a lot to say about the periodic table when we come to transition metals, or when we talk about specifically about group 2, and specifically about halogens in group 7 or 17. But then, of course, we spend more time on that. But generally speaking, things you need to remember: nuclear attraction and shielding effect, right? And also remember that nonmetals, these guys on the right side, they want to gain electrons, whereas metals on the other side, they want to lose electrons. Then you have to think, what makes them lose electrons better or easier with less energy requirements? Or for nonmetals, what makes them gain electrons? But no wonder fluorine is very, very reactive, isn't it? It's only got 2 shells. The nucleus is round the corner. It's going to attract electrons like mad. And no wonder potassium is also extremely reactive on the other side of the periodic table. Why? It wants to lose 1 electron from the outer shell. And then since that electron is not very strongly held by the nucleus, well, it's going to come out without much fuss. So shielding effect, the keyword, remember that one, and nuclear attraction, and the trend, like I told you. Okay, I think that would do for the lesson, 5 or 6 minutes of it, whatever it was, yeah? And then next time we talk about, in lesson 2, foundation lesson 2 for AS, I'll be talking about formula, and you might like that as well, how to actually generate and construct formula. All right, thank you.